Good morning to all. This is the problem number 2 from Thevenin's theorem. This is given in GATE 2015 WE code. It is given for 1 marks. Already we solved problem number 1. That contained only the independent source. So here is a circuit which contains dependent source. Here we have to find the Thevenin voltage. The question is, for the given circuit, the Thevenin equivalent is to be determined. The Thevenin voltage VTH seen from terminal AB is. So given circuit is this one. 20I is the dependent voltage source. I is the current passing through 1 ohms resistance. Okay. So this 1 ohms is connected across the 2 volt source. Okay. Let me solve the problem based on this. So for VTH, now AB is open circuit. Okay, let me draw the circuit again. Resistance, in parallel another resistance, and here dependent voltage source. This is open circuited. So AB is the terminals, this is open circuited, and here this one is VAB or VTH, Thevenin's voltage that we have to find. Here 2 ohms, 20I is the dependent voltage source, and 1 ohms, this is the current I, and here 1 ohms, and here 2 volt. Okay. So to find VTH, first we have to find the current I. Okay, to find the current I, we are applying the nodal analysis. Let me assume this as node 1 and V1 is the nodal voltage at the node 1. So by the nodal analysis we write the equation. So here V1 minus 2 by 1 ohms plus V1 by 1 to the grounded voltage, and plus V1 plus 20I by 2 equal to 0. So simplifying the equation, V1 into 1 plus 1 plus 1 by 2 plus 20I by 2, 20I by 2 equal to 2, so equal to 4. So this is simplified as 5V1 2. So here 5V1 by 2 plus 20I by 2 equal to 2. So the equation will become 5V1 plus 20I equal to 4. So this is taken as first equation. Okay. So let me we have to find the current I. So here from this branch we can directly write V1 by 1 ohms, that is equal to I. So V1 equal to I. Now we are eliminating V1 to find the current I. So we are substituting V1 value as I in the first equation and we will find I value, current value. So this equation will become, so V1 equal to I means 5I plus 20I equal to 4. So therefore I equal to 4 by 25, that is equal to 0.16 amps. So I we found out as 0.16 amps. Okay. So let me solve for dependent voltage source. So that is given as 20I. So 20 into 0.16, that is equal to 3.2 volt. Okay. So 3.2 volt is the dependent voltage source voltage. Now we will find Thevenin's voltage. Okay. So for the Thevenin's voltage, so to find VTH, again we draw the circuit. dependent voltage source that we found out as 3.2 volt, and this is open circuited A, B. So this one is the Thevenin's voltage, and here another resistance 2 ohms, 2 volt, 1 ohms, here also 1 ohms, and this we found 3.2 volt, and here 2 ohms. So this is the current I. Okay, I we found out. Okay, here now we are applying the mesh analysis only to find the VTH. Okay, so this is the VTH. VTH is the voltage across the terminals AB. It is nothing but voltage across 2 ohms. So we can write VTH as, voltage across 2 ohms, that is equal to 2 into I2. So let me assume this loop current as I1 and this loop current as I2. Okay, so by Kramer's rule, we are writing the matrix equation directly. Okay, so we are writing the matrix equation directly here. What? This is 1 ohms, this is 1 ohms. So 1 plus 1, 2, and here minus 1, and this one is 1 ohms, this one is 2 ohms. So 1 plus 2, 3, minus 1. Okay, into I1, I2, that is equal to, the voltage rises 2 volt for the first mesh and 3.2 volt, that is dependent source voltage, for the second mesh. What we have to find to find the Thevenin's voltage? We have to find the current I2. So we will find delta and delta 2. Okay, so delta equal to 2 into 3, 6 minus 1, that is equal to 5. And delta 2 is 2 minus 1, 2, 3.2 here, replacing the column. So 3.2 into 2, 6.4 minus, plus 2, that is 8.4. Okay, so I2 equal to, we find I2 equal to delta 2 by delta, that is equal to 8.4 by 5. Okay, so 8.4 by 5 is nothing but 1, 1.4, 6, and then 8. So I2 is 1.68 amps. So Thevenin's voltage, so VTH equal to, it's nothing but 2I2. So substituting for I2, 2 into 1.68, that is equal to 8 is 16, 3.36 volt. Okay. Okay, 3.36 volt. So we found Thevenin voltage as 3.36 volt. So the answer is V equal to, that is Thevenin's voltage equal to 3.36 volt.